Assalamualaikum and a very good day. We are from Section 2, Group 2 went to present about our Laboratory 2, which is a boundary layer and flow over immersed body. My name is Nur Shafika binti Adira. My ID is MA19094. I would like to present about the introduction for this laboratory. First is background. A boundary layer which is a very thin region of flow near a solid wall where viscous force and rotationality cannot be disregarded. The boundary layer approximation corrects some of the Euler equation primary flow by allowing the no-slip requirement to be enforced at solid wall. Uh, Flow over immersed body. Fluid flows over bodies is when to study and see how it is reacts when it passes through them. External flow is the movement of fluids over bodies that are submerged in a fluid. It is focused on the lift and drag force that arrests. External flow is defined by a freely developing boundary layer surrounded by a modest velocity and temperature gradient outer flow zone. The problem statement is when to investigate the speed for the two different surfaces which are smooth surface and rough surface. How the boundary layer thickness based on the two different surfaces can be determined, and how the streamline and can be visualized at the cylindrical body orifice and wing profile. Objective of this experiment is to study the speed distribution for flat plates. Second is to determine the boundary layer thickness of a flat plate subjected to longitudinal flow for smooth and rough surface. Lastly is to plotting streamlines over cylinder, orifice, and wing profile to identify flow conditions. Scope in this experiment is to study about the boundary layer on a flat plate. For this case, two surface is being used to determine the boundary layer towards smooth and rough surface. Moreover, we also study about the flow over immersed body on how to determine the streamlines that can be visualized at the cylindrical body, orifice, and wing profile. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Rosdalia binti Ramli and my ID is MA19101. So today I will be responsible to present the theory of boundary layers. So what is theory of boundary layers? So the boundary layers theory begin with Ludwig Pratt's paper on the motion of a fluid with very small viscosity, which was presented at the Third International Congress of Mathematicians in August 1904 at Heidelberg and published in the Proceedings of the Congress in the following years. So this paper marked an epoch in the history of fluid mechanics, so opening the way for understanding the motion of a fluid. So the genesis of the boundary layers theory stood in sublime isolation. Nothing similar have ever been suggested before, but no publication on the subject flow except for a small number of papers due to Pratt's student for almost 2 decades. So boundary layers have concept. So the concept is the limited solution Re is equal to infinity is often good approximation of the flow of fluid in many technical applications. So at large Reynolds numbers, this transition may place in a thin layer close to wall called by L. Pratt 1904. So these boundary layers or frictional layers. So the boundary layers is thinner than the higher the runner number. Example for the small the viscosity. So within the boundary layers, they have two different flow form mentioned in the previous chapter. So the flow can be laminar or turbulent. So one then speaking of laminar boundary layer flow or laminar boundary layers for short, the equivalence of tubular layers. So basically the concept of very simple. So they have boundary layers thinner than higher Reynolds number. So for the next method for this experiment, I will let my friends present it. I think that's all. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Badrul Amin Razak and my metric number is MA19082. Okay, today we present about method and procedure. Okay, we will go to the apparatus first. The following equipment is necessary to carry out flow pattern symmetric aerofoil at a different angle of attack. First, mobile rolling frame with benchtop, radial fan, switchboard and drawer for small parts, air intake pipe with throttle valve and thermometer. And also rectifier. And next, removable nozzle, funnel of air pipe, feature of 16-volt water pressure gauge, and measuring glands for measuring tips. Okay, next we go to the procedure for experiment number 1, which is experiment for flow of symmetric aerofoil at the different angle of attack. We call flow over the immersed body. First of all, we need to set up the experiment and attach the aerofoil model and screw it into the flow bench. And start the experiment with 0° angle attack. And the radial fan is allowed to move after the switch is turned on. Adjust the radial fan to 12 as the starting point. Record and tabulate the reading data. Next, press the smoke controller to emit smoke into the flow to see the flow of the air on the aerofoil. Then capture a picture of aerofoil flow. The speed of aerofoil is increased by 1 until reaching 90. And next, the last one is we need to repeat this experiment from step 5 until 8 using 30 and 45 degree. Okay, we will go to the procedure for experiment 2, which is flow over flat plate, we call boundary layer. First, we need to set up the experiment, then insert the smooth surface flat plate into the flow bench. Third, set the first distance to 0, then measure the after distance. Fourth, connect the pipette tube to the vernier caliper. Fifth, the first data is the pipette tube touching the flat plate surface. Sixth, switch on the radial fan and record and tabulate the data. 7. Adjust the plate distance from 0 mm to 140 mm by 20 mm. Although the distance of the pipette tube between flat surface also increased from 4 mm to 32 mm by 4 mm. And last one, we need to repeat this experiment from step 5 until step 7 for rough surface. I think that's all from me. Thank you.
Assalamualaikum and a very good day. My name is Ninur Ashikil binti Rajadullah, MA 19107. So for the result and discussion, for the experiment 1, which is the flow pattern of symmetric aerofoil at different angle of attack. So here we need to plot the drag and lift force at various angle of attack for different speeds. So to find the drag force and also the lift force for this experiment 1, we need to have the velocity. To find the velocity, we need to have the delta H. So to calculate the delta H, we are given by the inertial head. In the inertial head, we minus by the head and we have the delta H. And that delta H, we substitute in the velocity formula and we can get the velocity. Then we can find the drag force and also the lift force. After we find the drag force and lift force, we fill up the table and we can
plot the graph for the lift force adverse angle of attack versus speed, and also the drag force adverse angle of attack versus speed. Second, we need to sketch the streamlines of the airfoil at different inclination angle of attack. So these are the sketches for the airfoil at the angle of attack 0 degree, angle of attack for 30 degrees, and angle of attack for 45 degrees. The velocity on the top surface is lower than on the lower surface when going through the streamline. The pressure changes and the velocity change, the result of non-zero circulation around the foil. So for the viscous flow, the symmetrical foil at the zero angle of attack will not produce lift. Next, for the experiment 2, which is a flow over the flat plate. So in this experiment, we need to plot the head velocity and Reynolds number versus boundary layer of thickness for the smooth and rough surface. Just like earlier, to calculate the Reynolds number and also the velocity for this experiment. So to calculate the Reynolds number, we need to have the velocity, and to find the velocity, we need to have the delta H. To find the delta H, we can use the initial head minus head given. So we can get the delta H and substitute in the formula, we can get the velocity and also Reynolds number. And fill out the table. Here, in this experiment, we need to choose at one point, which is in this experiment, we choose 10 millimeters. So we plot the graph for the head velocity and Reynolds versus boundary layer for smooth surface and also for the rough surface. And second, we need to plot the velocity versus distance for plate for smooth and rough surface. We already have the distance of plate given, and we find the velocity earlier, so we can plot the graph for the velocity versus distance for plate for smooth surface and also the rough surface. That's all from me. Thank you.
Assalamualaikum and good day everyone. My name is Wanur Adibah binti Wan Hisamuddin, MA 19080, and I'm going to talk about the conclusion for the second experiment. So for the conclusion of this experiment, we are able to complete this experiment digitally at the end. We also complete a full fluid flow activity instrument and measured the drag and elevation forces that applied to a symmetrical aerofoil at the various angles of attack throughout this experiment. So the flat plate speed distribution has also been established. The boundary layer on a plate is influenced by the speed of the flowing fluid, the Reynolds number, and thus the roughness of the plate. So for this experiment, because the speed of the moving fluid increases, the Reynolds number can be increased also. And finally, in this experiment, we calculate the boundary layer thickness of a flat plate subjected to longitudinal flow for rough and smooth surfaces. So that's all from me for the conclusion. Thank you.